Using the grid lines as a basis, we're going to turn them into alignments. Go to Alignment, Alignment from Object, select the grid line of interest, accept the direction. I particularly like them facing downward, it's up to you. Make sure that you associate this alignment with a site, which again is with your original surface. I'm going to call it C1, or for cross-section 1. Yeah, a little bit easier than north, south, east, or west. Don't erase your existing entities in case you need to reuse them. Go OK. You'll notice that in blue you see the station points. I'm going to repeat this for each one of the subsequent grid lines. Select the object, accept the direction, give it a name that you can recognize, C2, cross-section 2, associate it with a site, uncheck erased existing entities, and go OK. So the task here is to do this for each one of the cross sections, which go from north to south, and each one of the longitudinal sections, which go from west to east. Giving it a recognizable name is recommended when you anticipate creating all of your profile views. Good. Files. Okay, now that I've created all of the alignments, I need to create all the profiles. You're going to create a surface profile. Now, notice here, you find the alignment that you made, and make sure that you add the surface so that it knows what to cut a section through. Now, you can go OK, but I prefer going straight to Draw in Profile View. Confirm the alignment, name the profile view. You can give it a description, C1, or something to that effect. And now anticipate the profile view. Notice I've created something called Standard No Z. And I'll just go Create Profile View, select it here, and then there's my profile view. I can zoom in, check it to make sure that it is of the correct dimension. I recommend this. So now I'm going to do the next one. Don't forget to add your surface and Draw in Profile View. Standard No Z. Now you also notice the display of my sections is different. I went into the surface styles and I turned off all the extraneous horizontal and vertical tick marks and changed their color so that they were lighter in appearance than the sections themselves. So you can see that I'm repeating this for each one of the cross sections. Now we'll begin creating the transverse. Same process as for the cross section, the longitudinal sections. Repeat the process of the cross section process. So go to Select from Object. You see I clicked my grid line there. Accept the direction. Associate it with the site. And now give it a name. So I think I'm going to call it T1. It really should be L1. I've done it again up here so to make sure that I don't get the cross and the transverse mixed up. Now I'm going to create a profile. Check, make sure it's the right alignment. Add your surface. Okay, Draw in Profile View. You're going to accept the defaults. There you go. Now, here's something you need to pay attention to. Is the baseline the same between the cross and the longitudinal section? So, in making this model, I anticipated that the lowest level that should appear on the model should be -20, so that there would be enough material to create the waffle. So, when you're setting up your Create Profile View, make sure that both the cross sections and the longitudinal sections have the same base, which should be -20. This will make it easier for you to create the sections in generic AutoCAD to make the model. So we're repeating the longitudinal section, changing our names so we can differentiate. Good. Okay. Then select your position away from the cross section. Add your surface. All right, and now you're done. Now notice that there are these small green boxes with text in them. Don't let that alarm you. That's just the technique and the information that's put forward by Civil 3D to let you know that the station points for the longitudinal section. So there we go. There's our second section. So now I'm going to create the last section, T5, add the surface, draw in profile view, create the profile view, and there we go. So now I have all the base information that's necessary in order to export these to AutoCAD for the model. Okay, this is an object-oriented modeler. Notice that the road profiles, right, are all one object. So when we export using the wblock command, we're going to export everything. So type wblock, give it a name, pay attention to where you're putting it. Notice mine's on my network drive. Select the objects. I use a crossing window. You don't have to be as precise as I am, but remember you only want that information. Okay, check the name. All right, happy? Yes. Okay. Include the map information? Yes. All right, the W block's been made. Now pay attention. I'm going to zoom in on the window here. Notice the longitudinal sections, my base is 0. And as I said earlier, it needs to be -20. Now your instructor paid attention when she made the cross section, not the longitudinal. So it's good that we have all this extra information to help us make the sections. Now that we've exported it, a W block from Civil, we're going to open it in generic AutoCAD. Let me note that you don't have to export the map information. It's a preference. But there is something special you have to pay attention to. So here you go. Now, we know that this is a series of object-oriented, so they're all related. If I explode everything, the potential is, and you'll see it here, that the sections in cyan go away. Not good. So I have a revised process. Even if you erase this, you'll notice that when you zoom in, the section information is missing. So the strategy here is that you need to explode things twice. First, you're going to explode the section, and then you're going to explode the supporting information, which is in the gray and the little bar, cyan, bluey cyan bar at the bottom. So, what you just watched was incorrect. Still incorrect. All right, because if you notice, the section marks and the longitudinal are gone. So, not good for us. Uh-oh. So, here we go. New drawing. Same drawing, different process. See? It's associated. So, I'm going to zoom in. And what I'm going to do first is explode, but of course I typed extend. So no, it's EXPLODE. And I'm going to select the section. Look, some of the map information goes away. And I'm going to repeat this for every cross section, and I'm going to repeat this for every longitudinal section. And then I'm going to repeat the explode process again so that I get the gray information, right, which gives us potentially, see if I did them as a multiple, they disappeared. So you're going to explode them one at a time. Sections first. Supporting map information second. All right, so if things blink on and off, you can remember the regen or regen all command, R-E-G-E-N, and then the option all. All right, so what do you have to remember? You need to remember that the base of the model is going to be at -20. So you want to take advantage of some of that leftover map information. All right, so even if I delete this, notice one of the sections disappears. So pay attention. Make sure it's properly exploded. So I'm going to have to Control Z, go back, now explode, so I get that very particular section right there. There we go. All right. And now if I erase that extra map information, it's not going to be a problem from the plan. All right. Okay, but hold on a second. Where's the gray stuff? So I'm going to explode, turn it, undo, bring back the gray stuff, and then use that to make the base, to make this the profiles that I'm going to use for the waffle, knowing that your instructor provided you with a jig or some base things to trim so that you can create the waffles that'll fit together. All right, so now I'm exploding all the grays so that I've got something to work with in order to find my baseline. So, the adage is true, expect problems and you will be fulfilled. Okay, so now we're going to sort of trim everything up and we're going to scale. So you can see that after exploding, right, there's all these little extra elements, which is fine. I'm going to use them as part of my tools, erase some things I don't need. And now, you know I need to sort of make a boxed up section. So I'm going to draw a line and another line. And now I'm going to check the distance to make sure it is 264. So I'm going to use dist, D-I-S-T, snap, 264 feet. Perfect. So everything came in at the right scale. So now I need to scale it down to model size. I'm going to select just the objects I need, use that base point as that intersection, and you can see I can rubber band it, but I'm going to reference it. So if that point to that point is 264 in model scale, I know it needs to be 13.2. So that's what I enter in, zoom in, and now you notice my model is to scale. Okay, so we've got everything scaled. We've got a rough idea about where the 0 is. We have each one of the sections. Now we need to insert the jig that your instructor made in order to make your life a little easier. All right, so you notice that you can download it from Canvas, but I've placed it in the network drive. And I do believe that it is called Waffle Jig or something close to that. There we are. All right, so you see there's one for the short section, 13.2, and one for the longitudinal, which is 16.5. At that grid interval, which is 33, 33, 66, 66, 33, 33, or 3 66s for the longitudinal. Now, they're in inch, so you have to explode them so that you can take advantage of it. Because what you're going to do is they're closed polylines, and you're going to snap it to the origin of the corresponding section. All right, now, I'm a little messy. You're going to go in there and be a tad more precise. So we've done that for the longitudinal. Now we're going to do it here for the short section. And then what you're really going to do is just start to edit, make sure everything's lined up, and anticipate the fact that for the longitudinal, you see the template for the jig will actually cut through both sides of the material. So you're going to have to shorten that, right? And then on the short section, they don't pass through the material. So you're going to have to lengthen those. And the rule is at least 50% of the material. If you go any smaller than 50%, you're going to have some failure or potential bending. All right, so now you can see where I'm headed. This is where it is that you're going to want to end up, which is to line up your jig with your section and then begin to edit. So the red jig is a polyline, so you're going to explode it. Hit enter, and now you're just going to go through an exhaustive number of trim and edit commands so that you can actually get a shape that the knife cutter will be able to cut out from the chipboard material. Alright, so I anticipated the groove to be the thickness of the 2-ply, a little bit wider than the 2-ply, which might be a mistake, but we can always tack glue it afterwards so that we don't get everything falling apart. Alright, so this process continues on. So with trial and error, a little bit of shifting, a little bit of erasing, a little bit of p-edit, everything should be fine. Now you notice I've got information on top of one another, so I got to delete some of this extraneous data that your instructor seemed to have left in her file. So file hygiene, important. At the end, to bring to the laser cutter, to the knife cutter, or the laser cutter, you can, this same process can apply to either. You need to bring a series of 10 closed polylines on a single layer at the correct model scale so that the knife cutter can follow your path. Alright, so good luck everyone. Editing here will continue for a bit. Make sure you check the wiki in order to find the instructions on how to save this file from AutoCAD so that it can be read by the knife cutter. And we'll make sure that you're working with the TAs or with Benjamin Rice regarding how to set up the knife cutter. All right, good luck to you.